Shall we start? Yes. We are going to talk about force. What is force? तुमका जे कितें understand जाता about force. What you know about force. I don't want any definition from the textbook or from anywhere. I just want to know what you understand from the word force. Force तुमका केन्ना apply करचो पडटा? What is force? To move something. Okay, fine. That is your understanding. Correct. Then push pull. Okay, same thing it is. What else you understand from the term force? Na anikay na taglin? No? Okay. Force are of different types. First, I'll talk about external force or applied force. What is external or applied force? The force that is applied by someone. Suppose हांव एक force apply करता, तेका कितें म्हणटली आमी? Applied force or external force. That is the first thing that we are going to talk about. Applied force, or it is also called as external, the one that we are going to apply. आता त्या फोर्सा खातीर what are the different forces that is going to generate that we are going to see. एक simple example दिता. There's a desk over here. I'm trying to pull it. How कितें apply करता? External force on this. I'm pulling it. Is it moving? Is it moving? No. आमी केला, pull केला. मातसो force apply केला. It is not moving. कित्याक move जायना? तुमचे assumption कितें? it is not enough, that force is not enough, or what you will say, this is heavy, something that sort you will say, right? Okay. See, if I'm standing here, someone is pulling me this side with 20 Newton. How खंयच्यान move जातले? I will move this side. माझो acceleration, my movement will be in this direction. ज्या directionan force apply करता, त्या directionan हांव move जावपाक जाय. Yes or no? Is there any other force acting on me? This side I'm saying, no. There is only one person pulling me this side. So whichever direction the force is applied, that direction I have to move. So if I'm applying a force this side, is there any force here? No, only this applied force. So because of this applied force, what should happen to this desk? So त्या directionan move जावपाक जाय. But to move जायना. Now come back. Someone is pulling me this side with 20 Newton and someone is pulling me this side with 20 Newton. Which side will I move? I will be at rest. Why I will be at rest? Because on the me, there are two forces acting. One in this direction, one in this direction. Force is a vector quantity. 20 Newton, 20 Newton. Direction kosa asa, two vectors going in opposite direction. What do you do? Subtract it. So 20 minus 20 is how much? 0. So what is the net force acting on me? Total force 0. And when net force is 0, what will happen to me? I will be at rest. Correct? Okay. I am applying a force. See, it is very simple. एक suppose object असा परत दाखयता. हे sentence suppose 20 Newton force apply केलो. जाल्यार this one had to move in this direction. Correct? But if I apply another force this side of say again 20 Newton, which side it will move? It will not move because F net will be what? F1 minus F2, that is 20 minus 20, which is 0. Because both are going in opposite direction. So what will happen to this object? It will be at rest. Now coming back to this point, I am applying a force this side. It is not moving, meaning how it is? At rest. At the rest are kenna astalo. If my force is 20 Newton, te sentence kide aspak jaye? 20 Newton. But where there is 20 Newton, someone is pulling it with 20 Newton, then why is it not moving? This is the concept, no? He sentence and he sentence force equal zalo zalaruts. F net will be 0 and object will be at rest. This is physics. This is what physics tells you. And which is true. So if I'm applying 20 Newton or 20 astana, but if I'm applying 1 Newton this side, still it is at rest. Mass is important. No, I'm talking about force over here. For concept, I'm talking about this concept. So if I'm applying a force this side, it is at rest. That means someone is pulling it in this direction. So who is pulling it? Is there someone standing over there? No. So whenever you apply a force, खंयच्याय ऑब्जेक्टाचे जेन्ना फोर्स अप्लाय जाता or force exert जाता, always remember there will be another force getting generated in the opposite direction. That force is called as restoring. Now this force is imaginary force. You cannot see it. आता तो कसो तुमका दिश्टी पडना? Is there someone pulling it? No, you cannot see it. Okay? Such type of forces are called as what? Restoring force. Now we are going to study about different types of restoring force. I'm telling you all, if you all are not listening, please listen, because these things are extremely important. So if I'm applying a force this side, also suppose if I'm applying a force this side, F is equal to 1 Newton. This is my applied force or external force. This object is not moving, it is at rest. That means opposite direction and कोण generate झालं? Restoring force. That restoring force is called as static friction. So who is not allowing me to move it? Now she said it is dependent on mass. Yes, static friction depends on mass, and that is why it is not moved. Is that clear? So when I'm applying a force and object is not moving, that time which is the force acting in opposite direction? Static friction. Now I have increased my force. Now I have increased my force. At किती जाता? Object is moving. So who will be in the opposite direction? असा static friction असतो. Static म्हणल्यार किती? Staticaचो what is the different name for static? Rest, no? So something it has rest, then it is static. Now it is moving. Now it is moving. Correct. So is there any force on the opposite direction? No? Then why have to apply a force then? Correct, no? If I wanted to move this, I must also pull केला आणि ओपाक जायशिल्लो if no one was pulling it on the opposite direction. Someone is pulling it in the opposite direction, that is why I'm applying a force, no? Continue मग तेका pull करत रावपाक पडटा. So when object starts moving, static friction आशिल्लो आता object starts moving, still I'm applying a force. So who is there on the opposite direction? I'm applying a force. And this one is moving. So who will be there on the opposite direction? Kinetic friction. My rolling friction bhi asa te आम्ही मागेर शिकूया. Right now I just want to tell you all about which are the different types of restoring forces. Okay, so friction सदाच कसो apply जातलो? Either it is static or kinetic. It will be opposite to the motion, not applied force. I'm telling you all again. Static friction सदाच खंयच्या directionan apply जातलो? Opposite to the motion. If see force is applied this side, so it is moving this side, movement is this side. So friction will be applied where? Friction will be applied where? Friction will be opposite to the motion. Very, very important one. Don't write anything right now. Let us talk about everything first. This is the first one. Friction will be opposite to the motion. First one cleared, Zalo? Let us come to the second restoring force. Can you see this fan? Which is the force that is acting on this fan? सांगत मग कोणचो force तुमका दिसता which is acting on this? Is there any applied force on it? कोणी pull करता कितें करता? No. Okay. So which is the force? See, force म्हणल्यार कितें? Suppose तो fan पडटा, जाल्यार तो कोणा खातीर? Movement तेजो कोणा खातीर जातलो? That is force. If the object is moving, it is moving because of what? Force. Because you are going to study this formula later on, but you know already this formula, right? F is equal to mass into acceleration. Because of force, what will take place? Acceleration, that is movement. Okay. So if you want to understand what is force, try to understand it that way. If object starts moving, it will move because of the force. So now tell me this, pen. हो मूव जातलो कित्याक खातीर मूव जातलो मूव म्हणल्यार कितें असो असो घुंवतलो ना कॅन दिस फॅन सिलींग फॅन गो हियर एंड कम नो तेजो मुवमेंट म्हणल्यार कितें ओन्ली वन मुवमेंट कॅन हॅपन वॉट इज दॅट इट कॅन फॉल डावन येस ऑर नो what can happen with this fan movement of fan means what I'm not talking about blades moving I'm talking about the entire fan moving so which is the only way a fan can move it can fall down so movement will be this now acceleration is this falling down so this acceleration will be because of which force yes we don't see never call it gravitational force it is called as weight of that object mg म्हणतात त्याला weight of the object okay this one will fall because of what its weight okay आता मधीच suppose तो पडलो तुटून not because I pulled it no it fell because of what because of its weight got it so second type we are going to study suppose of an assumption it is tied right with असं पळय तो बांधलेलो असेल so right now you know the only force acting on it is its weight F is equal to mg now what we just now studied whichever side the force is acting that side that object should fall or move accelerate if it is not accelerating if it is at rest right now it is at rest or no rest or asa that means rest केन्ना असता कितें असपाक जाय opposite forces should be equal there should be two forces moving in opposite direction जाल्यारूच तो कित्याचेर उरतलो at rest so now you know one force on it mg you told me about only one force त्या फोर्सा खातीर तो फॅन कितें जावपाक जाय आशिल्लो पडपाक जाय आशिल्लो but is it falling down no it is at rest that means who is present here as soon as a force gets applied on any object who gets generated restoring so which is the restoring force over here this one is at rest now so हांगा खंयचो force what downward आसा so restoring force खंय येतलो it will come upward anything that is tied this is also tied right anything that is tied rope asu it is not only vertically horizontally सुद्धा असपाक शकता anything that is tied will have a restoring force named as tension force what it is called tension force is that clear now if tension force is equal to this mg what will happen object will be at rest both are equal no object will be at rest if mg is greater than tension force it will fall down correct if mg is greater than tension force आता imagine करात हो फॅन जो आसा तो बारीक एक थ्रेडान टाय केला वयर थ्रेड बारीक थ्रेड यूज केला टाय करपाक कितें जातलो फॅन फॉल कित्याक फॉल जातलो बिकॉज इट्स वेट इज मोर देन द टेंशन मोर देन द स्ट्रेंथ ऑफ दॅट थ्रेड आता हो कंडिशन केन्ना येवपाक शकता what is T greater than mg सांगात बेगीन what do you mean by T greater than mg tension greater than mg कितें जातलो फॅन वचपाक शकता खंय रावपाक शकता yes सकयल पडपाक शकता yes is it ever possible for that fan to go on top केन्नाच जातले ना so this is never possible so tension can be equal to mg or it has to be less than mg or restoring force will be equal to the applied force or any force or it has to be less than what equal to or less than the whatever that force is okay आता tension force खंय generate जातलो if anything is tied मागीर तुमका MCQs असतले पळय for NEET JEE that time you will have the higher version of it let us not talk about it now okay tension will get generated only if something is tied इतले याद दवरा either vertically or horizontally म्हणल्यार suppose हांगा wall आसा एक thread or whatever rope tie केला and there is one object over here I'm trying to pull that object like this force apply केला external force I'm pulling it like this till when can I pull it suppose thread इतलीच आसा थ्रेड इतलीच आसा हांगा तो ऑब्जेक्ट आसा कॅन आय टेक दी ऑब्जेक्ट ओवर देर इतलो पुल करपाक मेळटा म्हाका मेळटा काय ना कित्याक मेळना बिकॉज लेंथ ऑफ दी थ्रेड इज दिस मच नो वॉट विल हॅपन पयलीं अशी आशिल्ली धरती अशी आशिल्ली आतां हांवें तेका पुल करून तेका स्ट्रेट केली कॅन आय पुल इट फर्दर सो हो कितें आयलो at rest. So who is present this side? Tension. Why it is at rest? Because tension became equal to external force. Okay, so tension where it can come? Any horizontal or vertical object tied. Is that clear? Third thing, I have this bottle. I'm keeping it over here. I have this bottle. I'm keeping it on the table. Which are the different forces acting on it? Bottle. F is equal to M. Always remember, खंयचोय object असो, weight of it will always act vertically downward. Weight of it will always act vertically downward. तुम्ही पडटा आसतना सदांच सकल पडटली अशी वाड्यान उडून हांगा ते पडची ना. Yes or no? So सदांच याद उरतली mg सदांच कसो act जाता vertically downward. Okay, so there is one force which is called as mg. Now because you can see only one force on this, because of that F is equal to mg, what should happen to this bottle? एकूच force असा, F is equal to mass into acceleration. एकूच force apply जाता. So what should happen to that bottle? It should fall down. But is it falling down? Force आयलो की कोण येतलो? If it is at rest, restoring force will come which will balance it out so that the object is remaining at rest. So आता हांगा restoring force खंयच्यान आसतलो? सांगा. F is m. This is at rest, no? So restoring force कसो आसतलो? This force is called as normal or reaction force. This restoring force is called as normal or reaction force. Friction सदांच कसो act जाता? Opposite to the motion. Opposite to the motion. Tension force खंय खंय येता? Only if there is any rope or anything that is tied. Rope असलो, thread असले जाल्यारूच tension force येतलो. बिश्टोच येवचो ना. Normal or reaction force कसो act जातलो? See. Can you see this? What is this? Surface of contact of the object. What is this? Object त्या surfaceाचेर दवरला. And how is the normal force to the surface? Perpendicular. So normal force सदांच याद दवरा. It is perpendicular to contact surface. It is perpendicular to contact surface, meaning where the object is placed. Is that clear? Okay. Yes or no? Ata next one, last one. What is this? Spring. This is what? Spring. Spring ani ho different na. This is your normal thread, rope or whatever. This is spring. So hanga a pull karat jali spring stretch jatli. So if you try to pull this side, F external, after some time it will stop moving. So हे संज्ञान कोण force येतलो generate जातलो spring force म्हणतात ते Fs. त्याचा एक formula असा Kx म्हणा, but I'm not writing it now. Let us study it later on. So F external will be equal to Fs, spring force. Is that clear? So tell me which are the different types of restoring forces that are present. Friction केन्ना generate जाता? ना तशें म्हणटली सांगा तुमकां कितें अंडरस्टँड जालां तें सांगात. Friction केन्ना generate जातलो? Which are the different types of friction you know? Static and kinetic. Rolling is also there, which we are going to study later on. Static and kinetic friction, when does it get generated? Static केन्ना जाता? As soon as you apply a force on the object, if the object is not moving, who is getting generated? Static friction. Kinetic friction, Once it starts moving, opposite to the direction of motion, what gets generated? Kinetic friction. Tension. Anything that is tied. हेका pivot points म्हणतात हेका हांगा connected points असतात पळय so tension force सदांच कसो वयता towards the pivot points. So these are called as, it always goes upward. Downward येवपाक शकना तो, it has to go upward. Or horizontally or vertically. Fine. Then comes anything kept on the table or something like that. So which is the forces present? mg is downward and the restoring force कोण असतलो हांगा? Normal or reaction force which is acting upward. Perpendicular to the contact surface. Perpendicular to the contact surface. And last one is spring force. इतले सगळ्यांक cleared झाले? Net force on any object केन्ना zero जातलो. When the force, equal forces are acting in opposite direction. Net force will be zero. If net force is zero, will the object move or will it not move? It will never move. Clear? Okay. I will give, if you all have understood this, how many of you all have understood this thoroughly? Understood this thoroughly? Okay. एक तुमका question देता. You have to mark and tell me which are the different forces acting on that object. There's a wall here. There's one object here. See here, I'm going to demonstrate करून दाखवता. It is something like this. Now you have to show me the direction of forces, different forces that are acting over here. In two cases, when I'm holding it like this and when it is falling down. When it is falling down. Getting it? Sollo हात झाला की जातलो? It will fall down. So you have to show me different forces acting on this. This is the bottle, this is the wall. Now, you just show it as friction. Don't write kinetic or static. Both the cases you have to show. See, I'm holding it like this. If I remove my hand, it is going to fall down. So which are the different forces acting on that object? त्याचे पहिले आहे ते कॉपी करतात जाल्यार करात then you write it. Quickly mark it and show me. No, there only you should. Yeah. Or okay, you can show separately as well. Mark. आणि दोन forces will. Kelly Ravidal. दाखव. You can show it in the same figure I'm saying. Same figure and the first one what you have shown. That is why I was stressing again and again on these statements. Read it again. There we go. Directions I want. Proper arrows आहे. इथे आम्ही कसे काढल्यात arrows. I want those arrows. आता एकदा काही नाही काढलं तर. One more is left. Restoring असते ना. It is not that way. Which are the different forces acting on that when I hold it and when it is falling down? That I want to know. Restoring nire baba. Which force? Restoring are of different types. Which restoring force? So कल किती मार्क केलते? हाँ? External नहीं, weight घालप ती. काय रे? करू ना? What? आता इथे दिष्टी पट्टा arrows मारल्यात ते आम्ही. You can see. I want such arrows. Don't write anything. There's nothing to write there. You have to show it in arrows. Like how I have shown it over here. Here. Arrows at least. No, this is wrong. What is this stuff over here? Done? From where tension came there? What is tied? Is there anything tied over there? Then I'll repeat again. Then you mark it. If object is moving because of any force it might be, not only applied force, any force, if the object is moving, opposite direction and kunja force applies atlo frictional force. Now don't draw, she has drawn separately, but that is correct. I think only one force was left to write. You can show it in a single figure. If object starts moving, opposite direction and कोण येतलो frictional force. एक झालो. Then object move जाता, तो आता कित्याक खातीर move जाता? Applied force खातीर move जाता, or is it moving because of some other force? That force will come in the direction of motion. Will there be tension over here? No, because nothing is tied. It is just a wall and a object placed. Okay. If it is a wall and the object is placed touch to it, then code atlo thoi contact surface atlo. Object is in contact with the wall, no? So who will come in picture over there? Normal force. Normal has to be perpendicular to the contact surface. एक 40 try करा था, otherwise I will show you. Let us discuss. First thing was what? Start from the first thing. I'm holding it like this. It is not falling down. It is at rest. Okay, so which are the different forces? I am holding it. So, कौन first at law? External force I law. In which direction? Towards the wall. Which direction? Towards the wall. So you can show it like this or show it like this. It is one and the same. How you can show it over there? Parallel shifting, yaad asa? Parallel shifting of vectors. Third chapter we have studied. You can shift the vector from here to here. So keep it here or keep it here. It is one and the same. Ek zalo. When I hold it over here, ek zalo majo applied force. Which is the other force present? Object is at rest, no? Object is in contact with the wall. So who will come into picture? Now the like força खातीर हो भितर वचपाक जाय आशिल्लो वॉलाच्या. There is only one force present. If there was only one force present, this bottle would have gone inside the wall. Because of the force, acceleration जावपाक जाय आशिल्लो. But जाता ना. Object is at rest. That means opposite direction नानूय खंयचो तरी force act जाता. So which is that force? Which is that force? Contact surface. Who is balancing out this? Normal force. Got it? Now, if I leave the bottle, which side is it moving? कोणा खातीर move जाता? Which force? Because of its weight. mg खातीर it will move downward. Its movement is downward, so upward motion downward जाता. So who will come in the opposite directions? Friction will be. Now, why I have told you all to show it in a single figure? Because normal will be present throughout, no? Yes or no? So, kalpatta asthana object bitar bahir gavasna. Yes or no? So, it is present throughout. So, you can show it in a single figure. So all these things are clear to you all? Yes. Friction you are going to study in detail at the end of the chapter. In detail means full, complete study astali त्याची. Okay. So but these are the different types of restoring forces. हो जो concept असा तो वोकार सदाच यूज जातलो. With respect to vectors, it is basically two vectors in opposite direction, two vectors going in same direction, which we have already studied in your first third chapter. Okay. Next, let us come to the Newton's law. ऐकला केन्ना? न्यूटनाची कितली laws असतात? 3 laws असतात. Let us first talk about Newton's first law of motion. Okay, then comes second. आणि कोणतं तुमका already खबर असा? Which one you know? Third law खबर असा. What is that? Every action has equal and opposite reaction. Okay. Let us come to Newton's first law of motion. Newton's first law of motion is dependent or based on inertia. Ever heard about this term? Inertia. What is inertia? केन्ना ऐकला स्कूलान? तुवें ऐकला आसतलें CBSE. गोवा बोर्डाक आसता? 9th आशिल्लें. Okay. You all must be having it in detail. So, what is inertia? State of only being in rest. See, this is actually what I'm trying to tell you all. तुम्ही स्कूलांतल्यान थोडे concept शिकून आयला, but you all studied it just to by heart it. Yes or no? So, as I'm telling you all, from this chapter onwards, logic starts. So please don't by heart question. तशेंच येतले अशें ना. There will be twists and turns. मागीर तो मास्टर twist जालो जाल्यार answer करपाक कळपाक जाय. For that, you should know the concepts thoroughly. The friction. You are marking friction in any direction. See. That is not correct. Motion ज्या directionan जातलो त्याच्या opposite directionan कोण असपाक जाय? Friction. So that logic should be there. Is that clear? Okay. Let us come back over here. So let us talk about inertia. Anything in this universe, Ami Suddha, or any object, anything has a property within it which is called as inertia. Now, what does that inertia does? Suppose if any object is at rest, in the state of rest, then inertia within that object will always wants that object to be at rest. Suppose आता हांव रेस्टार आसा, जाल्यार inertia within me want to do what? I want to be at rest until and unless some external force is applied on me. Other way around, if any object is in motion, if I'm moving, inertia within me wants me to be in the state of motion until and unless someone applies an external force on me to stop. जसे तुम्ही आता शिकपाक बसतात, शिकपाक बसू ना. तुम बसपाक जाय शिकपाक. Then what you do? याद धरपाक सांगता. What you do? You all want to sit and study. बसतात सामकी जपाजप बसून बसतात. Inertia within you all what it wants to do? त्याच झोनान रावपाक जाय. शिकपाक नाका. Then who applies an external force on you? Mother. So that is inertia. केन्ना उलटा जाला तुमचे बरोबर? If you are studying, then you be in that state until someone exerts an external force on you to get up from there. Na to inertia hoita mai. Then you get up on your own. So try to remember it that way. Okay, so just read that second page. Newton's first law of motion. Every body continues in its state of rest or uniform motion unless an external force acts on it. Yes? Okay. आता definitions येवपाक शकतात. State Newton's first law of motion or second law of motion or third law of motion. So याद दवरा, nothing to by heart. You just have to remember that. आता inertiaचे तुमका applicative questions येतात. You get applicative questions. I have given the question as well as the answers, but let us discuss those questions over here. When a horse suddenly starts running, the rider falls backward. Why? Horse रेस्टार आशिल्लो. ओके ते तुम्ही यू मस्ट हॅव नोटिस्ड इट इन दी बस एज वेल और बाय कार सुद्धा फाटल्यान बसता तेन्ना रेस्ट आशिल्ले. स्टार्ट सडन स्टार्ट करून स्पीड धरली जाल्यार यू गो बॅकवर्ड. बसीन सुद्धा तुमकां बॅकवर्ड जग मेळटा. आणि फॉरवर्ड जग केन्ना मेळटा? हा सडनली सपोज स्टॉप जालो जाल्यार यू गेट अ फॉरवर्ड जग. Same thing happens with whatever rider on the horse or you sitting in the bus or on the vehicle or somewhat like that. Why it happens? But how you will answer? So this is the question where suddenly starts running. It was at rest and it suddenly starts running. So what you will say? Initially, the rider as well as the horse was in the state of rest. When the horse starts running, inertia within the rider wants to be in the state of rest, but his lower body is connected to horse, so external force is applied by the horse on the rider. As a result, he gets a backward because he wants to be in the state of rest, but horse is taking him forward. Okay, so that is the answer. Read kara take 40 full answer. See, you don't have to by heart and write, huh? Please, by heart karpa gela, things will become complicated. You have to answer it in your own words. Read the answer. खंयच बरयलं पळय, कंटिन्यू केला. This is because so and so. झाले वाचले. फर्स्ट वनच रीड कर आता. सेकंड वन, dust is removed from a hanging carpet by beating it with stick. झाडू बी मारता घरान, क्लिनिंग बी करतात. हा केन्ना डोरमॅट बी घेवन अशें केला डस्ट काडपाक? ना करू ना. हा केला. कित्याक करतात तशें? Why you do that? Tap tap tap. And what happens then? The dust falls down. So how does it fall down? Dust and carpet or whatever, doormat, both were in the state of rest. Pahili boropak jay, this is because of inertia म्हणा. Then you start with this. So dust and the carpet both were in the state of rest. You are applying a force on what? Carpet. Dust will, inertia within the dust wants it to be in the state of rest. So when you apply a force on the carpet, carpet goes backward, dust will remain there. Carpet fatlan gele, dust inertia kadi thoy chullo, it will fall down. Read it. Done? When we shake the branch of a tree, its fruits and dry leaves fall down on shaking. Why or how? केल्यात कोणे ही कामा? Anyone has done this? Yes. So when you shake the branch, the fruits and the dry leaves fall down. Shake करून कशी ती पडतात? Because of inertia. The मुखार सांग. When you shake the, everything was in the state of rest. Then when you shake the tree, you are applying the external force through that branch on the fruits and leaves. Inertia within the leaves and fruits wants to be in the state of rest. So to shake jata, to rest utta, it breaks and it falls down. So you just have to answer it in your own words. Nothing to by heart. Okay, read that first. Read it. Next one. When a horse running fast suddenly stops, the rider is thrown forward. Running suddenly stops, thrown forward. Now what you will say? Because of inertia. So what happens here? They were in the state of motion. Inertia within the rider wants to be in the state of motion. But since his lower body is connected to the horse and the horse is coming to rest, external force is applied on the rider. Okay, so he gets a forward jump. A person getting out of a moving bus or train falls in the forward direction. त्यांना पहिला आहे experience केला बसीन ते conductor बी भारी उडी मारतात, they fall forward and they run and then gain that inertia, but they tend to fall forward. So again, what you will say? He was in the bus, the person was in the bus was moving or train was moving, so what was their state? Motion. Inertia within that person wants to be in the state of motion. When he jumps out, his legs come in contact with the ground, which is at rest. So he wants to be in motion, legs coming in the contact with the ground at rest. So he gets a forward jump. Read. So if when that person is jumping, if you want to save himself from falling down, what he has to do? Run, because instant rest राहिला तो पट्टलो. So if he run for some time, what will happen? So आपली स्टेटान रावपाक try करता, then automatically it will come into the rest state. Next one, sixth one you just read. It is little bit different from what we studied. An athlete runs for a certain distance before taking a long jump. This is because velocity acquired by running is added to the velocity of the athlete at the time of jump, or we can say inertia of motion gained by him at the time of jumping helps him in taking a longer jump. Long jump करता असताना आम्ही डायरेक्ट येऊन जम्प करपाक शकना. We have to run for certain time. आता running करून आम्ही किती करतात? We gain inertia. Okay, when we gain inertia, you can jump for a longer distance. Next one, when a vehicle moves, the mud sticking to it will fly off tangentially. You get a question on this saying why mud guards are used in vehicles. Why? Boron side in boron dorpa शकतात. Question point number 7. Why mud guards are used in vehicles? Why mud guards are used in vehicles? You know what are mud guards? यांका खबर असतले चलन. खबर असा? What are mud guards? आता असणार नाही व्हेइकलांक, but those are inbuilt type, I guess. पहिली ते असताले flap type, those old cars. Now they have those inbuilt one, black color. So normally तुम्ही बायकाक बी पहिला असतले, those pilot bikes बी असतात त्यो, old bikes. फाटल्यान टायराच्या फाटल्यान black colors असो flaps असता. पहिली those old Maruti 800 cars and all, if you see, they will have those, I think front will not have, only back ones. Back tires असतात. Front असणार आहे. Front कशा असतले? मध्ये घालतले ते? I don't know. I actually don't know much things about automobiles. I just come and I just go. So I was when I was thinking about this, I was thinking whether my car has that or not. But then I realized it's just in a black part like something. But that is in the build type. Initially, they were having those old cars and all. They were having some like 15-20 years back. They were having those black color square part astalo tire फाटल्यान. ते कित्याक आसताले आता बायक बी असतात पळय बॅक टायर ऑफ बायक त्याच्या फाटल्यान तो फ्लॅप्सो आसतालो ब्लॅक कलर दोज वे कॉल्ड एज मड गार्ड्स नाव वाय आर दोज प्लेस्ड मड गार्ड्स कित्याक प्लेस करतात टायराक कितें लागलेले असता मड ओके सपोज तो मडगार्ड नाशिल्लो तो मडगार्ड प्रोटेक्ट करता फ्रॉम समथिंग सो मडगार्ड नाशिल्लो टायर गोज राउंड एंड राउंड लायक दीस सो टायराचो तो मड जो आसा तो कंटिन्यू काय चिकटून उरना तो fall off jata. Now when it is falling off, see, mud is connected to the tire. Tire is going round and round and round. So mud also wants to be in the state of what? Circular motion. Direction तेजो कसो असपाक जाय round and round and round. But it is falling off. So fall off जाता आसतना तो कसो fall off जातलो असो वयतलो काय it wants to be in the state of motion, no? Circular motion. So it will go how? Tangential. So तसो वयता आसतना the mud कोणाचेर उसळटाले it was coming on someone who is walking or something like that. That is why those mud guards were placed so that the mud tejer protect करतालो. I mean tejer येतालो and it was protecting the people. So that was the thing of mud guard. If you have not understood this, last one एक point असा तो सांगता. No, just listen. If you tie a small stone to a rope and you or thread and you try to whirl it like this, what will happen? The stone will go in a circle, round, 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 circle and wetlo. It is in the state of what? Circular motion. आता मधीच suppose तो तुटलो stone threadaच्या तो कसो पडटलो will it go down ठक्क सकल पडटलो vertically no it wants to be in this inertia wants to be in the state of what circular motion but it has to fall down also because circular it is not connected to anything no cut off zala so it will not immediately fall down it will go in the circle and tangentially it will go and fall. Understood? So that is the thing about mud guards. Why mud guards are used? You can read that. This is due to inertia of direction. The mud guards over the wheel stop the mud protecting the clothes. During the sharpening of the knife, the sparks coming from the grindstone fly off tangentially to the grinding stone. This is due to, again, inertia of direction. Have you all ever seen grinding of the knife? Knife धार काडटा ती पयला not your manual type तशें राउंड एक हे आसता मागीर स्पार्क येता पळय थंयच्यान वेल्डिंग टायप अशें जाता स्पार्क येता सो दॅट स्पार्क हाव इट गोज आउट tangential again the same thing and the last one is what I just now explained and the stone tied to one end of the string. I read that. Just go through the things again. I will not do anything further because in the other branch as well, they were having exams yesterday. So तांकां इतलोच पाठ केल्लो. So I have to send them the video. So my extra करून धाडपाक मेळचो ना. So that is why I will do only this much. Just go through it. Just go through all these things. कॉलेजीन कोणतो चॅप्टर स्टार्ट केला? ग्रॅव्हिटेशन केला. लॉज ऑफ मोशन जावन अजून. तुमको केलो? Laws of motion done? Done already? When? Before? Oh, okay, before they do this chapter as well. I mean, what is there for the next exam? तुमको केला रे कोणा? You are from Rosary. What about your? What finished? Entire thing? Entire portion? I thought entire portion. Laws of motion is done. How many days they do? 3-4 classes. What about it? Not done. Gravitation is going on. किती करतात ते? Which one? That was not there for first term, first exam. आता स्कोर करपाक जाय नेक्स्ट एग्जामीक. You all are doing good. I'm happy with you. But still, how much you got? What happened with chemistry? Chemistry was difficult. Hmm? Lengthy paper. No, that is one college. मागीर दुसरे भुरग्यांचे कितें जालें? All have scored less, I guess. युजिको कितले पडले रे? Chemistry. तेका पडले मरे बरे. How come you all got less? How much you scored? कितले? 4, I guess. You scored well. You all got chemistry? किती सांगले ते गाणं 11. Vidal? You have scored less, I think. Or you scored less? 14. Chemistry कोणाक less पडलेले ते? Which college? I think there, I guess. There, in that branch.